Amazing. Thank you everyone for joining today. I'd like to begin today by acknowledging the traditional custodians of the land on which we are all joining from today and pay my respects to the elders past, present, and emerging. I extend that respect to any Aboriginal and Torres Strait Islander peoples joining us here today. Today we have Ross Donaldson presenting his work on embodied carbon, guides to designing carbon out, and dematerialisation. Ross Donaldson was CEO and chairman of Woods Bagot from 2006 to 2016. Living in Hong Kong for 10 years, he led the firm through its global growth, becoming the sixth largest firm in the world, and in 2016, named the seventh most admired in the WA 100 survey of 2,000 international practices. Prior to Woods Bagot, he had his own small firm in Perth and taught at UWA for 20 years. Since returning to Perth, he has become deeply involved in climate action for the construction industry and has prepared two series of lectures for the profession on designing for carbon. He continues to teach at the schools of architecture, provides mentoring for mid-career young architects, and strategic consulting to a number of our national architecture firms. Additionally, Ross is the founder of EPM Experimental, chairman at Bridge 42, and member of the Institute's National Climate Action and Sustainability Committee. Before we begin today's session, I'd like to ask that participants leave their microphones off and to save any questions for Ross until after the presentation. Thank you. Ross, over to you.
Thanks, Liam, and thanks for joining everyone. It's always a wonderful thing to be hanging out with young folks. So I'm talking about decarbonisation today, not surprisingly, and with a specific focus on embodied carbon. And the central theme around embodied carbon is really about dematerialisation, kind of less stuff. There's huge gains to be had by rationalisation, whether it's structure or other aspects of a project, to make massive gains in embodied carbon. And it's probably a bit easier than everybody thinks. It's certainly easier than the general discourse seems to be about it. And I'm going to do that by talking about 5 separate sources of inspiration or information. There's work that the Royal Institute of British Architects have done with their climate action document that was produced in 2020. There's a very interesting case study of the city of Vincent here in Western Australia, and their work around requiring life cycle assessment. And then I'm going to go on to Carbon Trace, and these two are basically focusing on the residential sector. Carbon Trace is an amazing platform that Tom Petty in Victoria has put together, and I'll elaborate on that when I get there. And finishing up with two of the world's leading engineering firms, Arup and Bureau Happold, focusing primarily on the carbon in structure. And in the background context, of course, it's impossible to know what everybody knows. You don't know what you don't know in this context. And just as a brief scene setting for that, the general move in terms of measuring carbon in buildings is based on a European standard EN 15978. And this diagram is a very simple representation of the different phases in the life cycle of a building. And these are the phases that are used for measuring carbon. There's the product stage, A1, A2, and A3, which is basically raw material extraction, transport associated with that, and manufacturing. And some of the references are going to be using today are only focused on that aspect of upfront embodied carbon. Then there's the construction phase, A4 and A5, with the transport of all the materials to site and all the site construction and all the energy associated with using that. Then there's the in-use stage of the project, which I won't talk much about, but some of the measurements do include this, and the end-of-life stage, which is recycling, hopefully, and demolition, but hopefully not disposal to waste. There's a circular economy element to it, and whilst the RIBA refer to the circular economy, I really won't be today. So just today focusing on embodied carbon, upfront carbon during the product stage and construction stages A1 to A5. So first document is the RIBA's climate challenge from 2020, and it's an interesting document to look at in terms of the scene setting that they include in a couple of diagrams, tables from their document, which talks about operational energy at the top and business as usual, which is what they were saying was the British sort of average project, business as usual projects this is the commercial sector. And they were setting targets for 2025, reducing the energy consumption in the building, and by 2030, more than halving the energy consumption in the building. And that's based, they're using kilowatt hours instead of CO2 here because of the rapid rate of the greening of the British grid, and not wanting to get caught up in the fact that the electricity supply will be fairly green fairly quickly. They want to keep the focus on reducing the energy consumed. And embodied carbon, 1,400 kilos. Don't worry about the numbers too much, but it just shows the British have a fairly advanced thinking in terms of driving carbon down. And they have a table for other classifications of buildings, in this case, new schools and residential as well. There is some correlation between these numbers and the others I'm going to be showing, but I don't want today to be too focused on the specific numbers. It's all about how you drive the carbon down and the percentage gains you can make. And to that end, the city of Vincent has an interesting case study example, because in 2018, all those 6 years ago, they started requiring, and they're still the only local government association that does this. They require a life cycle assessment report with all development approval applications. And they worked with eTool then, now Circlos, to develop a simple analysis tool called Rapid LCA, which is a much cheaper and simpler way of getting a life cycle assessment report, so that people could do their submissions on that basis. And by 2020, they set a reduction target of 15% better than business as usual, which was, I think, the 2010 National Construction Code equivalent. The fascinating thing about this is that by requiring people to measure and report, it straight away changed the culture of design. So designers were then focusing on trying to reduce the carbon, and the outcome of this simple shift of requiring reporting is that now they are now achieving something like 70% reduction, and on whole of life carbon in their case. So from 2,000 kilograms per square meter for a residential building, they're now down to 600 kilograms per square. It's an amazing progress just on requiring reporting, and they've had major gains in improvement in water consumption as well. These outcomes have been achieved through passive design and lowering operational energy, double glazing, low embodied carbon materials, incorporating of photovoltaics, water saving appliances, using water tanks to capture water, and water efficient gardens and no swimming pools. So some quite simple steps that's really in everybody's remit, really. And alongside that, there's a fantastic piece of work done by the fantastic Tom Petty, his platform called Carbon Trace, and he's taken the NatHERS database that CSIRO carry for all residential houses in all residential developments in the last 10 years. He's got a database of 10 million. He knows the embodied carbon of every house in Australia built in the last 10 years. It's quite remarkable. And sorry, this diagram's not great, but it just illustrates a sort of scattergun effect of where the average across the whole country is. This is just A1 to A5. It's not during the construction phase itself. And he's shown that by you can get the target, the embodied carbon down from 175 to 79 kilograms per square meter. That's just on the upfront A1 to A3. So it's a lower number than much lower number than Vincent are talking about, because this is whole of life carbon, but it's a 55% reduction simply by getting rid of concrete slabs and heavyweight construction, lightweight construction, a metal cladding and double glazing. Just those simple design changes can dramatically reduce the embodied carbon in a building by over 55%. But just to give you an example of his database, the average embodied carbon for A1 to A3 in WA is 234, mainly because of the common use of double brick and concrete slabs here. Victoria's 168, New South Wales 173, and Queensland 100. I'm not sure why South Australia is not there, but you can see that everywhere other than WA is in a similar sort of territory because of the construction systems. And now getting on to the engineers and moving up to a different scale. This is a document produced by Arup in 2020 with the World Building Council, and just focusing on structure. And so this is a sort of modest scale commercial building, if you like, and it shows that where the body carbon is. So in the skin, it's about 15% on the left-hand side there. Space planning, petitions, etc., about 10%. Other stuff, FF&E type stuff, 5%. Services, 20% of the embodied carbon, but 50% of the embodied carbon's in structure. So the real target is in structure. And I might skip over this one. It's probably too much information to absorb in a short amount of time. But I would commend you to look at this document by Arup, because it shows you a whole sort of range of different strategies you can attack for reducing the embodied carbon in your building. And there's great gains to be gained by refurbishment. If that's not possible, then there's all sorts of other strategies around facade and structure and so forth. And they include in there the embodied carbon for different floor structures. For example, just to give you a taste for what the document's like. So you can see their standard flat plate chews up a lot of carbon, and the lowest one is a ribbed slab, which is less than half, about a third of the flat plate in terms of the embodied carbon in that floor plate, structure. Now, flat plates are popular because they're cheap for formwork and rapid to build, and ribbed slabs are more expensive. But then there's a trade-off between the amount of concrete that you're using in the structure versus the simplicity of the structural system. So another ready reckoner that you can seek out. And this shows that the taller the building, the higher the embodied carbon. So height is a real killer for embodied carbon. We should always seek lower rise solutions. And then finally, the Bureau Happold piece, which just develops this in a bit more detail. They've got a fantastic document, very simple, ready reckoned guide to embodied carbon in structure that they put out. And I'm just going to touch on a couple of aspects of this as I wrap up. So they've taken a simple building, about 36 meters by 36 meters, 7 stories, 6 stories, simple, bog standard commercial office building typology, just as a reference building. And they've measured the embodied carbon for a concrete slab structure, flat plate structure, a steel structure, and a timber structure. And I just want to show you the impacts of how you can initiate design decisions that will impact on the structure. So this, standard flat plate structure with columns, with a column grid of about 9 meters, will give you about 331 kilograms of CO2 equivalent per square meter. And that's just, again, A1 to A3. I keep because the numbers are sort of up and down all over the place, but the key thing is the percentage of reductions you can achieve. Now, if you can use cement replacement, and there's a limited amount of cement replacement products in the world still, but you can get that at 331 down to 175. And if you shift the column grid from 9 down to 6.5, you can get it down to 200. So you can nearly halve the total quantity of embodied carbon in these structures by cement replacement or the structural grid. Or you can look at different floor slab structures, and you can see here the movement from the 331 number down to 245, 35, and 190 with different structural systems. I certainly don't expect you to absorb all that as I'm talking now, but this information is available. But they've done it again for steel. I won't try and take you through all that, but you can see all sorts of different design decisions around grids and loadings and footings and floor slab systems, and the same for timber. And interestingly, they compare the 3 structural systems of reinforced concrete, steel, and timber, and you can get them. So I'll go back. So if you take every strategy you can with a reinforced concrete slab, you can go from 331 to 54. You can take nearly 80% of the embodied carbon out of a concrete structure with still being a concrete structure, just by rationalizing the structural system. Steel you can get from 227 to 66, and timber you can get from 142 down to 41. So it's in the hands of the designers with their structural engineers to be making these decisions. And we don't have to rely on new materials, although you can include some blast furnace slag or some other kind of cement replacement to help. You don't have to have new structural construction systems. We're using existing supply chains, availability, and the kind of systems that everybody on site's already used to. So major changes, major improvements to embodied carbon can be done just through design decision making. We're the designers. We have control over that. There's no reason why we should be abrogating that responsibility. So here you can see on the left-hand side um, the different steps in the structural system. Um, so, and the thing that I think's amazing about this, in terms of what's in our power to take command of with these sorts of decision making, is that is not in itself a basis for choosing between concrete, steel, or timber. They all end up around the same if you rationalize the building and optimize the system, so you're not wasting material and pushing structure beyond what it needs to do the functional job. And finally, Neighbours is in the process of building a new platform for us to report embodied carbon. They've been reporting operational carbon for years now, of course, and pretty soon there'll be a product out on the market that'll be a national standard for how we measure carbon. So there we are. Dematerialisation is the key to decarbonisation. Thanks very much.
Amazing, Ross. Thank you so much. I just sent in the chat. If anyone has any questions for Ross, to feel free to put them in the chat. But I'll start off the questions and answers period with a question of my own, which is since beginning your career in architecture, what sorts of shifts have you seen in the sustainability space?
Well, interestingly, I mean, I've been around a while, so I graduated way back in the 70s, actually, and there was a lot of interest in those days in the basic notions of passive design, sensible design around climate, um, and it got lost. I think it got lost because a lot of to do with politics and lobbying, sort of during the 90s, I think somewhere. In the 80s, there were lots of advocates for around the risks of climate change, and it's come back. But it's recently, it's only relatively recent that it's come back with science, real science, to understand the implications of climate change and the ability to start calculating the carbon effects of our design activity.
Yeah, absolutely. I guess speaking of sort of calculating and getting some really, I guess, strong numbers, especially something that's a bit more objective, like you're saying. How and where can students, grads, and by proxy fellow practitioners, I see a lot of them in the chat today actually. How can they find resources to begin to start integrating sustainability focused principles into their everyday workflow?
Well, a really simple start is something like Rapid LCA, which is a surplus product that I referred to that was developed in conjunction with the City of Vincent. Now, whether they provide access to students, I'm not exactly sure, but Rapid LCA in itself I should stop sharing my screen, I suppose, shouldn't I? Um, um, Rapid LCA, I think it's between $60 and $100. So now that may not be appealing to a student, but certainly for practitioners, it's a very inexpensive way of getting a quick and reasonably useful level of accuracy and understanding the carbon in your building. There's lots of different life cycle assessment tools around the world. I mean, one of them is eTool, which was developed in Australia. It's an Australian product and used around the world as well. Um, I think the main window to pass through in terms of understanding the implications of your design decisions are and that's why I put them in this presentation. There is material around that can give you a sense of what design decision making will impact. Using less concrete in a house unless you can get carbon replacement materials for the cement, cement replacement. Lightweight construction rather than everything being brick, although that's really a major problem in Western Australia, not so much the rest of the country. Not designing a building so that it puts more stress on the structure, so that you're overstressing the structure and therefore using a lot of carbon in doing so. So it's not a simple answer to that question, Liam, but it's there are good materials that MECLA have produced. Their spotlight talks. There's quite a few materials that the Institute of Architects have, which should be accessible to members. So, but it is a bit all over the place still, I have to say.
Absolutely.
Making a start, I think it's getting started is the key thing.
Fantastic. I have a question from Nicola over here. Hey, Ross. How do we convince the clients and stakeholders that cheaper is not always better? Actually, it's never better, but it seems they only care about money and not the environment nor future proofing.
Oh, I love this question because I mean I think it's conventional wisdom that you know say sustainability costs money. It can, but it doesn't have to. So the main emphasis of this talk has been about taking design actions that will not only reduce the carbon, reduce the cost. So if you're taking material out of the building, you're taking money out of the building. If you're using less concrete because you rationalize the structure, whether it's a fancy house or a small office building or a school or whatever it is, it will cost less as long as you don't overly complicate the construction systems that you have to employ to reduce that amount and reduce the quantities. So that is true whether it's a timber structure or a steel structure or a concrete structure. Um, I have to say there's a lot of lauded timber projects that are sort of lauded as being the future of the profession and the future of construction. But two things I would say about that. One is there will never be enough timber to rely just on timber unless we really get into a circular economy, which who knows how long that's going to take in all honesty. But secondly, a lot of timber structures are still trying to be spectacular, and they're massively oversized columns and beams because large spans and things. The same with timber structure as it is with a concrete structure. Don't use excessive spans unless there's an absolute, like it's a sports facility or something where you simply can't have columns. That's one of the big gains is from reducing structural grids from 9 to 10 meters down to 6 or 7. So it's not going to be more expensive, it's cheaper. But we need to develop a degree of technical knowledge to be able to argue that with the client. Put the Bureau Happold report in front of them.
Fantastic. I have a question from Katie as well. Apologies if this is too left field, but wondering on your thoughts on our attempts to put in place whole of country approaches to sustainability, energy efficiency, etc., and the impacts on rural and remote communities.
Well, I think I certainly wouldn't profess to be an expert in this field. I shouldn't. I mean, but I've obviously been part of a heck of a lot of conversations about it in recent years because it's very much the currency. I think the basic principles, as I appreciate them to be in terms of thinking about country, are really very strongly applicable initially to principles of passive design and things like don't build any more than you need to build. Ideally, recycle what is already there. I mean, the biggest gains are to reuse our existing building stock, and I think that aligns with notions of First Nations approaches to minimalisation of don't use more than you need, and reuse it and put it back and try and leave it as you found it. So I think at that level, there's some very basic principles that are applicable.
I also have a question from Sanya. I hope that I pronounced it correctly. Sorry if I haven't. But how do you approach designing buildings that have many heritage protected buildings in its site context, and or regulation that oversees the appearance of the building?
Well, that's a big question.
Mm,
Um, well, the risk of restating, I think the biggest gains um, in the future will be from the reuse and the repurposing of existing stock, whether that's houses or office buildings or schools or institutional buildings or whatever. Now, there will be times where the program for the next iteration of the building's life is challenged by the existing fabric of the building. You're not going to change the 1930s primary school into a sports hall, really obvious examples like that. And if you absolutely need the sports hall and don't need the primary school anymore, you're probably faced with having to demolish it. But do it in such a way that, if it's built out of bricks from that era, then all that stuff will be recyclable because the mortar was then used is you can clean the bricks. In terms of the guidelines that are associated with heritage context, it's probably a little bit out of the context of this conversation. I mean, I used to do a lot of work in that in the old days, but if I start on that, I think we'll need another half hour. Can't hear you, Liam.
Sorry about that. I have one more question from Salvatore. I hope I'm pronouncing that as well. How would you convince the Victorian government that demolishing high-rise public housing towers is not a sustainable practice if the structure is still suitably kept and DOA refurbishment instead? I guess maybe as a bit of a filter to that, then how would you justify then, or rather convince a government's body that demolishing a pre-existing building is not sustainable, especially when there's still usable structure?
Yeah, it's a very good question, and I have a little awareness of I have some awareness of the Victorian question. I think part of the pathway to that is um, is innovative thinking about what the models for residential accommodation should be, rather than assuming the actual footprint of those buildings is inflexible to the point of adapting to current expectations. Those decisions are often made preoccupation of more bedrooms than one needs and lack of appreciation of where the real demand in the community is now. Certainly, the embodied carbon and whole of life cycle carbon analysis can be done to indicate that you would have huge gains by keeping what's there. Um, Personally, I think it's probably a lot of vested interest stuff in the background that's actually driving a lot of that thinking, and that's very hard to overcome with arguments about life cycle assessment. They have to be have to be tackled head on in terms of calling out that vested interest and with an argument about the creative repurposing of those buildings.
Fantastic. Thank you, Ross. I have two more questions to ask you before we wrap up today's session, unless anyone else has any questions to ask. But my first question being, have there been any new developments in the sustainability space that you'd like to bring to more people's attention?
I think they're the ones that I've just talked about, actually. I mean, I think there's a lot of really good thinking. There's a lot of leadership, and I think the ROBA and Bureau Happold and Arup, are putting the material out there for us. We have to do a bit of work. I mean, as a profession, I think we have to be prepared to do a little bit of hard work about getting to understand these things and seeking them out, because there's a lot of material that can help us to know how to do better. The analysis tools are getting better. The neighbours one that's coming, I'm sure, will be an extremely good national standard for us all to be doing it the same way, which will make it easier to be arguing with government. Because one of the current counters that are often used is, the different ways of calculating give you different results. I think for us as designers, we should put all that aside and just say, okay, we just want to halve the carbon. I don't care if your report says it's 100 and my report says it's 200. Let's halve it. Let's get half of that carbon out of there. So I think that's where the game is right now.
Yeah, absolutely. And just as a final question to wrap it up, what got you interested in sustainability and what gets you excited about where the sustainability space is going?
Well, I actually got interested in the basic principles when I was studying. When I mentioned, where the world was back in the 70s and 80s. I think it started then, really, and it's evolved since then. I mean, in the work I was doing at Woods Bagot, I was, lucky enough to be traveling a lot, and I used to speak at quite a lot of international conferences around, um, you know, urban systems, city scale stuff about how to reduce the emissions at a city scale, working with Bureau Happold actually. Um, but I think where we're at the moment, we are on the cusp of I do believe, a massive and substantial ground shift in community attitude, and we're now getting more and more sophisticated tools that will enable us to do the job we have to do, is help us do the job we have to do, should be doing as designers. Um, and I'm more confident than I've ever been that we're on the cusp of some reasonably significant regulatory environment changes. I think the National Construction Code has announced intentions for 2025 and 2028 in terms of starting to measure and starting to think about benchmarks on the basis of using the neighbours platform when it's fully operational. And that's taking a bit longer than we'd hoped it would, unfortunately. So if we can get the regulatory environment to shift so that we're all in the same framework of having to drive the carbon down, and we know we have to, I do think it's going to herald an era of major re-engineering of design practices where we will be designing to a carbon budget. Based on the NCC announcement, it's possible even as early as 2028 our studios will all have to be designing to a carbon budget, not just a dollar budget. And I think we'll be better at designing to a carbon budget than we've proven to be to a dollar budget, because we'll have the tools in real time to be checking the outcomes of our design decisions. So I feel optimistic about that.
Absolutely. And I think that's a great note to leave off on. Thank you so much, Ross, and thank you so much, everyone who's been attending here today. It's been really, really insightful, and it definitely does get me even more excited to be part of the sustainability space. I guess in terms of a little bit of housekeeping for sustainability stats for the rest of the year, this will be our last one, unless otherwise posted, but the last one so far scheduled for 2024. So for all of you who've stuck around for all the sustainability snacks from this year, thank you for joining us. We have some really exciting ones lined up for next year, so watch the space for everything else in between. So again, thank you so much for joining us, and the recording will be posted online. Thank you.
Thanks for having me along, Liam. Cheers.